All right, let's dive into one of the most fundamental tools in all of science. It's the engine that takes a simple idea and turns it into hard evidence. This is the journey from a hunch to a fact.
You ever have one of those aha moments? A big idea, a claim, a feeling that you've figured something out. But then comes the hard part, right? How do you take that spark and actually prove it? How does a personal belief become a proven fact?
Well, it almost always starts with something simple. So let's picture a farmer. She's been working on this new fertilizer, her own special formula, and she's absolutely convinced it makes her crops grow taller. It's a fantastic claim, but right now it's just a claim. How in the world does she prove it to everyone else? Okay, before she even starts measuring anything, she needs the right tools for the job. You wouldn't use a telescope to look at bacteria. You need the right lens. And when you're looking at data, there are really two main lenses you can use to see what's going on. On one hand, you've got descriptive statistics. Think of this as the what is lens. It's straightforward. It just describes what's right in front of you. Our farmer can measure her crops and say, the average height of my fertilized plants is 15 inches. That's a fact, but it's a fact only about those specific plants. The real power comes when you switch lenses to inferential statistics. This is the what it means lens. This is where you take data from a small sample and make a huge leap, drawing a conclusion about the entire farm. It's how you can say something like, we're 95% confident this fertilizer works everywhere. Now that is a powerful statement. And making that leap requires a very specific guide.
To make that jump from a small observation to a big conclusion, you can't just wing it. Researchers need a compass, a North Star that guides every single step of the investigation. And that compass has a name.
It's the hypothesis. And the name itself is actually super helpful. If you break it down, hypo basically means tentative or subject to verification. And thesis is just a statement about a solution. So, put them together, a hypothesis is literally just a tentative statement that's waiting to be tested. I love this quote from John W. Best. He calls it a shrewd guess. It's not a wild stab in the dark. It's an educated, calculated starting point. It's formulated specifically to explain what you're seeing, and more importantly, to give your entire investigation a clear direction. So let's be crystal clear on this. A hypothesis is a statement, not a question. It proposes a possible relationship between things. And it's always forward-looking. It's a prediction that's ready to be tested. Honestly, it becomes the absolute pivot point that the entire research study revolves around. Now we get to the really cool part. To truly test an idea, you can't just go looking for evidence that you're right. That's just human nature, but it's bad science. Instead, science demands a fair fight. It requires a showdown. Think of it like a title fight. In one corner, you have your big idea, the claim you're excited about. That's the alternative hypothesis, or HA. It's the challenger saying, yes, there is a difference, there is an effect. But in the other corner is the reigning heavyweight champion of skepticism, the null hypothesis, or HO. The null is the default belief. It just shrugs and says, nope, nothing special is happening here. There is no effect.
So, let's put our farmer's claim in the ring. Her alternative hypothesis is her big idea. This fertilizer makes plants grow taller. But the null hypothesis is that tough opponent, the skeptic, saying, nah, this fertilizer doesn't do anything special. Any height difference you see is just random chance.
And here's the crucial twist. Your goal isn't to prove your idea is right. Your mission is to prove the skeptic is wrong. The whole point of the experiment is to collect so much overwhelming evidence that you can definitively reject the null hypothesis. So, how much evidence is enough? How do you score a knockout? That's where we set the rules before the fight. We pick a significance level called alpha. This is our line in the sand. It's the odds that we're willing to accept of being wrong, of rejecting the null when it was actually true. We set the bar high, usually at 5% or even 1%. That becomes our standard for what counts as proof. So how do we put all these pieces together? From that first shrewd guess our farmer had, all the way to a final proven fact, there's a clear, well-trodden path that turns ideas into knowledge. And here is that entire quest laid out. It's a 7-step recipe for discovery. First, you do the setup. You define what you're studying, you state your two competing hypotheses, and you decide on your alpha. Then comes the action. You grab a sample, collect your data, and run the right statistical test. And that all builds to the final moment of truth. Based on the evidence, do you have enough to reject the null hypothesis, or does the skeptic win this round? And that's why this whole thing is so important. This structured step-by-step process is the firewall. It's what separates what we want to be true from what we can show is true. It's the guardrail that keeps us from confusing wishful thinking with real scientific evidence.
So I'll leave you with this to chew on. Now that you know the framework, now that you know how to set up this scientific showdown, what's a widely held belief, something maybe you've heard your whole life, that you would love to put to the test?